In this video, I am going to show you how to list all the potential zeros of a polynomial, and then how do we find the actual roots from that list or outside the list. Okay, the first thing we do is so this is the given polynomial. Okay, the first thing we do is you list the p values. P is the factors of the constant number. P is always the factor of the constant number, so it is -16 here. And what are the factors of -16? It is divisible by plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8, plus and minus 16. So these are the numbers that divide 16. So you list all those values and we denote that by P. And we also list Q. So Q is the factors of the number that is a leading coefficient, factor of the number that multiplies the highest degree term, that is a factor of 1 in this case. Okay, so what are those factors? So plus minus 1 only. Now the potential roots are the ratio of P and Q. So these are the potential root. So here it will be plus minus 1 divided by plus minus 1 is plus minus 1 itself, and then similarly divide by 2, 3, 2, 4, 8 like that. So it will be plus minus 2, plus minus 4, plus minus 8, and plus minus 16. Okay, so these are the list of potential root. So next thing what we do is, so we want to check whether all of these numbers are root or not, right? But checking all those numbers takes more time. So what we do for easiness, for convenience, is we draw the graph. We plot this function in the graph. In your calculator, enter these things in y equals to, in y1 equals to, okay? So after you plot this, you will get this graph for that function. From the graph, you can see that the graph crosses x-axis close to 1, where 1 is not the root. Okay, you can check in the graph like second, and then trace, and then value. Hit enter. Once you select the value, hit enter, and you will see x equals to, you can try x equals to 1, and then see y. If you get y equals to 0, then x equals to 1 is the root, and then also try x equals to 4. You will get y equals to 0 at that time. Okay, so x equals to 4 is the root. Again try x equals to, it is like between 5 and 6, so 5 is not the root, 6 is not the root. So from the graph you can say that only 4 is the root. Okay, so you will get, when you said x equals to 4, you will get y equals to 0. So from the graph and in calculator, you don't have to draw the graph in the test or exam. Okay, what you do only is use calculator to draw the graph, and then you do second, trace, and the value, and plug in those values you suspect. Okay, and you can take the values from here, this list as well, because this list has plus minus 4. We don't try all those values from the list, only try those values that make sense in the graph. Okay, so from the graph you got that x equals to 4 is a root. We found that x equals to 4 is a root, because when you plug in x equals to 4, then you got the value of the y is 0, meaning that the remainder is 0, right? Remainder 0 means x equals to 4 is a root. Now still we need to find 2 more roots, right? Because it is of degree 3. Degree 3 polynomial can have at most 3 roots. It could be real or imaginary, but it can have at most 3 roots. Okay, so we're going to find the remaining roots. How do we find the remaining roots? Use the synthetic division. Okay, so we know that 4 is a root. Okay, now what is the highest degree term? X cubed, x squared, x, and then constant. Now write down the coefficient. So coefficient of x cubed is 1. Coefficient of x cubed is 1. Coefficient of x squared is -10. Coefficient of x is 28, and the coefficient of the constant is -16. You complete these, and then what you get here is 1 is 1, 4 times 1 is 4, and then -10, and then plus 4 is negative 6. Negative 6 times 4 is negative 24. If you add that, you will get 4, and then 4 times 4 is 16, because this is the dotted line, you see that. Okay, and 16 times 16 is 0. So what is the quotient here? So the quotient is x squared, because this is x cubed means this is x squared, x and then constant, right? So x squared minus 6x plus 4. The next step is, we found one of the root is 4, and the other two roots are the roots of this polynomial. Okay, since this is the quadratic function, what you do is you solve this for x. So you set that quotient equals to 0 and solve for x. How do you solve this? Use the quadratic formula. Okay, so set that x squared minus 6x plus 4 equals to 0. Okay, and then use the quadratic formula. What is the quadratic formula? X equals to negative b plus minus square root b squared minus 4ac divided by twice a. So what value did you get there then? So this is equals to negative b will be negative 6, right? Negative 6, and plus minus square root b squared is negative 6 squared minus 4a is 1, c is 4, divided by 2 times 1. What do you get? You got 6, because negative 6 is double negative is positive 6, and then plus minus square root negative 6 squared is 36 minus 16 divided by 2, right? What do you get? So you got 6 plus minus, okay, square root of 20 divided by 2. So basically square root of 20 is 6 plus minus square root 2 times 5. Those are the factors of 20, right? Divided by 2. So from this pair, you can take one number out. So you can write, let me write it here, equals to 6 plus minus 2 square root of 5 over 2, whole over 2. Now we split the denominator. What do you get? You got 6 over 2 plus minus 2 square root of 5 divided by 2. So you divide, so you'll get 3, and you cancel that. So what is the final answer then? The final answer is 3, and then plus minus square root of 5. So that is for this quadratic quotient only. But what is the overall? So what are the total roots? So the roots are, so you can say that the roots are 3 plus square root of 5, 3 minus square root of 5, and then 4. So these are the 3 roots. So this is how you find all the roots. So first of all, you list the roots once, and then graph it, and then test one of the value that matches in the graph, one of the value from here that matches in the graph, and once you get one of the root, use the synthetic division. Okay, if you get 2 of the roots from the graph, then you do the synthetic division twice. You can do that too. Alright guys, thank you.